This is for Year 12 methods. It comes out of trial number 1 for the application task, Deck Aloud. Question 3, part A. We know it goes through 1, 2, 3, 4, 5, 6 points. So it could be an ax to the 5 plus, or an ax to the 4 plus, or an ax to the 3 plus, an ax squared plus, or it could be linear. Don't know, but I'm going to put it into statistics and have a little look. When I put it into statistics and I do a regression, when r squared equals 1, then I know I've got a hit. So I'm going to trial and error and put it into a number of regressions and check and see where I get a perfect hit from. So okay, so if I go to graphs statistics, I've already pre-entered my numbers, so 8 and negative 361, etc. So if I go to calc, regression, and I'll do quadratic first. And I go okay, my r squared is 0.78, so it's not quadratic. Okay, touch back up here, calculate regression cubic. Bingo, r squared equals 1, and the sum of all errors is basically 0 because that is 7.41 by 10 to the negative 22. So move the decimal point 22 spots to the left. That will be the sum of all the errors, so therefore it's almost a perfect, well, it is a perfect fit. So it's a cubic, so it's going to be 1x cubed minus 12x squared minus 14x plus 7. That's going to be the general rule. If I was to continue this and actually do a calculation of a quartic, I also got an r squared equals 1. However, my value of a is 2.194 by 10 to the negative 13. 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2, 1, 9, 4, which effectively is 0. Because I'm in the statistics part of the calculator, I don't get exact answers, I'm getting approximates. So this is approximately 0. So if I'm working on the premise that I've got ax to the 4 plus bx cubed plus cx squared plus dx plus e, then I've got 0x to the 4 plus 1x cubed minus 12x squared minus 14x plus 7, which is exactly what I got here. So by going a quartic regression, it just gave me the quartic coefficient as being 0, and then of course the cubic coefficient and the quadratic and the linear and the constant was the same.